All right, so we're going to be looking at definition of a composition function. Given two functions, f and g, the composition function f of g is defined as f of g equals f of g of x. So when we're looking at composition functions, we're plugging one function into another function. We did function notation last time where we evaluated f of 2. So we input that 2 into the x of that f function, and we got our answer. We're going to be doing the same concept, except once we plug into these inside function, that it gives us a new input. And that new input will then go into this outside function, f, to get a new value. So we're going to be looking at composition functions. So here we're going to be using a composition function in something that we've used before in everyday life, which is when we're going shopping and you're going to buy something and it's at a discount. Well, how do you know how much you're actually paying? This is where a composition function comes in. We first need to figure out what the discounted price is, and then we use a function for that discount, and then we use a function for the purchase price, which includes our sales tax. So we're going to be plugging some value of x, which is the original price of the shirt, to get the discounted price, and then we use our discounted price plus our sales tax to get our total price of the item. So we're talking about this t-shirt here. It's discounted at 20%, which means we pay 80%. Sales tax rate is 6%, so we pay 106% of that shirt. We're going to find the purchase price of the t-shirt if the original price is $15. So our discounted price function comes from how much we're paying. We're paying 80%, so 0.80 of the original price of that shirt. For the sales tax, since we're paying 106%, that's 1.06 times the price of the shirt. Well, once we figure out the discounted price, we're going to plug that into our purchase price. And that's how we work with a composition of functions. So we're going to find P of D of 15. So remember I said this is the same thing as P of D of 15. We always work inside out. We're going to work on this first D function. Well, my D function, according to my discounted price, is 0.80 times our X, and our X is 15. So this gives me here P of 12, which means the sales price of the shirt is $12. It was $3 off. Well, now that we know the price of the shirt, we're going to do P of 12. So we're looking at our P function now, which is 1.06 of that price of the shirt, which is $12. We multiply that together, that gives us 12.72. So the sales price of that shirt comes out to $12.72 with that tax. So we're going to be doing that same concept. We're going to be first figuring out our inside function, plugging that into our outside function. So f of g of 3, we're going to be doing this inside function first, g of 3. So that's f of, and then in my g function, anywhere there's an x, I'm going to replace that with a 3. So this is going to be 3 minus 9. 3 minus 9 ends up being negative 6. So now we are going to figure out f of negative 6. So looking at our f function, 2x plus 5, anywhere that there is an x, I'm going to replace it with a negative 6. So this becomes 2 times negative 6 plus 5. We multiply and add, we get a negative 7. So f of g of 3 is negative 7. Next, we're going to look at g of negative 6. We're going to do this g of negative 6 first. So we're doing f of g of negative 6, which if we look at our g function is our x minus 9. So anywhere that there's an x, I'm going to plug in a negative 6 minus 9. So we're looking at f of negative 15. So going back to our f function of 2x plus 5, I'm going to replace my x with a negative 15. So this becomes 2 times negative 15 plus 5. Plug that into my calculator or in my head. Negative 30 plus 5 is negative 25. Letter C, again, we're working inside out. We're going to start off with this f of 1 first. So we're just using two f functions here. So we're going to do f of 1 first. So looking at my f function, 2x plus 5, we're going to do 2 times 1 plus 5. So 2 times 1 is 2, plus 5 is 7. Now we're looking at f of 7. So I'm going to input my 7 where my x goes in my f function. So it's 2 times 7 plus 5. And that gives me 2 times 7 is 14 plus 5 is 19. Now, here's where people see g of f of 3 and they say, well, I did f of g of 3. Shouldn't it be the same answer? Is it the same? Let's try it out. So we're going to do our f function first. So we have g of f of 3. So we're going to plug in a 3 in my f function. So it's going to be 2 times 3 plus 5. 2 times 3 is 6 plus 5 is 11. And now we're going to do g of 11. So anywhere there's an x, I'm going to replace it with an 11. So this is 11 minus 9. And that gives me 2. Notice that those are not the same. So the composition of two functions is not commutative, meaning you can't always just switch them. Now, does not necessarily produce the same output. So sometimes you might have the same output, but it doesn't always come out to be that way. Then we're looking at algebraic. So now instead of having a value that we're inputting, we have a variable. The concept is still the same, except my answer is going to have x's or some variable in the answer. So just like before, we're going to figure out our inside function first, or g of x. So we're doing f of g of x. So I'm going to replace my g of x with the actual function, x minus 9. So we're looking at f of x minus 9. Again, we don't have just some integer to plug in. We have a whole expression. And now, anywhere in my f function that I have an x, I'm going to replace it with this whole expression. So we have 2, and then in parentheses, we have x minus 9, and then plus 5. So we do our distributive property, combining like terms. We get 2x minus 18 plus 5. I'm going to combine those like terms. We get 2x minus 13. So my answer here is an expression, 2x minus 13. Next, we have g of f of x. Again, we're probably not going to get the same answer. So we do our first function, our f of x. So this f of x goes inside of the g of x. So our g function is x minus 9. So my x is 2x plus 5 minus 9. And again, because there's nothing in front of those parentheses, I can just delete those, get rid of those. And then just combine our like terms. So we have 2x minus 4. Again, these are not the same. They won't always be the same. Lastly, we have g of x. So we're doing our g function and we're plugging it into our g function. So g of x is x minus 9. So anywhere in my g function of x minus 9, in my x, I'm going to plug in x minus 9. So it's x minus 9 minus 9. So again, because there's nothing in front of the parentheses, we can just delete those. So we combine our like terms here, we get x minus 18. So anytime you are doing a composition function with x's or x plus h or any kind of variable, your answer is going to have x's in them or variables in them. We're going to skip through domain. And the last thing we're going to do is we're going to be using our graphs and tables to answer these questions. So just like before, we're going to work our way inside out. So we're going to do our g of 1 function first. So in my g function, which is this parabola, I'm going to go to g of 1. So when my x is 1, my y is 1 right here. So f of g of 1, well, g of 1 ends up being 1. Now I'm looking for f of 1. So I'm going to go to my f graph at x equals 1 and go to my line, and my y value is 3. So f of 1 is equal to 3. So f of g of 1 is equal to 3. Finding g of f of 0, so we're going to start with our inside function. So we're looking for f of 0 first. So at 0, my y value is 2. So g of f of 0 is equal to g of 2. And now we go to our g function. And at 2, we go up to our parabola. And the y value there is 4. So g of 2 is 4. Therefore, g of f of 0 is 4. I'm going to skip over to D. Again, we're going to do our inside function first, f of 3. So we're going to go to our f function. So at 3, f of 3, the y value is 5. And now our j of 5, we're going to go to our table. And at 5, our y value is 15. So j of f of 3 is equal to 15. So again, composition of functions, we're working our way inside out. We're plugging in to one function. That output becomes the new input to that second outer function.